Let's look at task 9, Hayley and Company Land Surveying. Hayley is a land surveyor at Hayley and Company Land Surveying. She is preparing to survey a parcel of land for her new client, Mr. Broomfield. Mr. Broomfield has just bought the parcel of land for his new farm and needs to have its boundaries verified to confirm its value. Hayley needs your help to complete the following tasks. 1. Confirm the shape and size of the land Mr. Broomfield has bought. Establish the boundaries of an additional parcel of land. And confirm the price of the land that Mr. Broomfield has bought. Before we go, let's just review a few things here. So we have certain shapes. So this is an equilateral triangle. Okay, all sides and angles are equal. This is irregular. This is a square, regular square. This is an irregular four-sided quadrilateral. Or so we have 1, 2, 3, 4 sides. Okay, so it's irregular. This one is a regular pentagon. This one is irregular. So we have 1, 2, 3, 4, 5 sides. This one has 5 sides, but they're not 5 equal sides. Regular hexagon here. So for this one, we have 1, 2, 3, 4, 5, 6 sides. 6. This 1, 2, 3, 4, 5, and 6. 6 as well. But these are equal and these are not equal. Let's take a step further. Oh, let me just lock this figure in place. All right. All right. So here we have the irregular heptagon, irregular heptagon, regular octagon, irregular octagon, regular nonagon, irregular nonagon, regular decagon, and deca has 10 irregular decagon. We move over and look at some more shapes. So here are some shapes. Let's lock this one in place as well. So this is a circle. All right, so this one is a circle. This is a triangle. This is a rectangle, an ellipse, a square, right triangle, right angle triangle, parallelogram, parallel sides are equal. This is a heart, rectangular prism, cone, cylinder, star. We got a question the other day that spoke about what shape we would get inside of this. Trapezoid, rhombus, cube, pentagon, hexagon, heptagon, octagon, decagon. Take another look here. Circle, triangle, square, rectangle, pentagon, hexagon, octagon, oval. We didn't get that one before. Rhombus, semicircle, parallelogram, trapezium, square-based pyramid. You see at the bottom of it, it's square, and it has the apex. Okay, cylinder, hexagonal prism, cube, cone, triangular prism, sphere, and cuboid. Those are some basic facts regarding shapes. All right. So if we look now at the first section, it says that we need to, part 1, do the verification. Part 1, we need to do the verification of the parcels and their shapes and size. So it says the map below shows the parcel of land that Mr. Broomfield has bought along with the surrounding lots. The boundary pegs are labeled. So we have one lot here. This is another one, right? And this is another lot. This is another lot. Let's say we label these lots here and call this lot A. We could call this one lot B, C, and D. Now, what are the shapes that are there? So this one is a square. Okay. So this one is a square. This one, this one, this is a right trapezium. Okay. This one is a right trapezium as well. And this one, they say, is an isosceles trapezium. Okay. Let's fix the spelling on this. There is an extra L. So let's go back. Isosceles. I think that's it. Isosceles. All right. So we have our shapes named, and we also must make note of the scale that is here. This will come in useful in a bit. So when it goes horizontal, it's 2, and on the diagonal, it's 2.83. All right, so we have that established. Let's look now. Mr. Broomfield's parcel is one of the 2 congruent parcels of land. Which 2 parcels of land are congruent? Explain your answer. So first of all, we need to know what this word here means. This word congruent. What does congruent mean? All right. Let's quickly take a look at congruent and similar shapes by Corbett Math. That's the YouTube channel there. So we're just going to watch his video, which is pretty short. It's a minute, 38 seconds. So let's go. So he says if 2 shapes are congruent, they are exactly the same shape and size. So he has A, B, and C. Now, oh, they are all rectangles. Okay, we can see that. But which 2 are the same shape? That means they're all similar. But which 2 are the same shape and size? All the same shape, but only A and B would be the same shape and size. So now we know that we know what congruent is in terms of shape and size. Let's look now at the shapes here and see if we can find out which ones are congruent. So this is a square. It has 4 equal sides, right? And the square's boundaries are M to N, from N to S, from S to R, and from R back to M, okay, in a clockwise direction. Now, let's look at shape B. This goes from N to P to U to T to S, and from S back to N to close that shape. Now, I see 1, I see 2, 3, 4, 5 moves here in order to get that to close. 1, and the shape is different. This is, so A and B cannot be the congruent, you know, shapes there or plots of land. So we already know that these are trapeziums, okay? All right. But this one, oh, look at this. This side is straight and this side is straight, but this slanting like this must be these two. These both are right trapeziums. Okay, so these two, so shape B and D are the ones that are. So which two parcels? So we could say here, uh, let's see if we can type this then. So shapes B and D are congruent. That is all right, let's use the word because then. Because they have the same size and shape. For example, the length of the sloping side of each. Let's see if we can make this a little smaller and move this up. Let's see here. No, just this. Yes. Then pull this across. Right, let's see. Is the same being equal to? Let's look at this here. So if this is from here to here to here to here to here, how many of them I have? I have let's see, go 1, 2, 3, 4. All right, cool. And let's look at the same thing now for the other part. And I see it goes 1, 2, 3, 4. All right. Now what is that using the key? It would be 2.83 meters by 4. Okay, let me see if I can put this somewhere here. 2.83 multiplied by 4. 4 threes would be 12, right? 2 and carry 1. 8 fours, 32 and 1, 33, right? 3 and carry 3. And 4 twos, 8, 8 and 3. That would give us 11. So decimal point, 2 decimal point there. So it's 11.32 meters. So this length here should be 11. Let's use another color. Let's see if we can swap. All right. I didn't want to use back red. Let's use blue. So blue too pale. Let's use black. 11.32 meters. Okay, so that's the length there. And again, 1, 2, 3, 4. So this should also be 11.32 meters. Okay. All right, so let's see. Um, let's test this as well. So over here it would be 1, 2, 3, 4, and this is 8. So this is 2, so 4 twos would give us 8. So 2, 4, 6, 8. So right here, so should be 8 meters. So let's see, this side matches with this side. So P and Q would be the same as T and U. So let's go 1, 2, 3, 4. Okay, so 2, 4, 6, 8. So this side is 8 meters as well. So this side is the same as this side. This side is the same as this side. Let's see. Oh, this side is the same for both of them. All right, so this is 1, 2, 3, 4. So this is 442 is 8. So this is also 8 meters for both of them. So we have a long side now. So this will be 1, 2, 3, 4, 5. No, 5. Hold on, let's get that one. Let's go. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 times 2. So this length here, all of the long side, would be 16 meters. Okay, 16 meters. So let's see if this is the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 16 meters as well. So it is the same size and shape. The dimensions for all of them, for both B and D, would be the same. Okay. Um, and if we wanted to, we could give some more details in this, right? So we say, for example, here, um, let's get this here. So shape B and D are congruent because they have the same size and shape. For example, the length of the sloping side of each of them is the same, being equal to, and we could write now 11.32 meters. Okay, the length, the length of the long side of both, that is, and that would be UV, for shape. No, let's start with shape, the one that is above it. Shape B, that would be N NST. Shape B. Shape B NST is 16 meters, and the length, not length, the long side of shape D, capital, shape D, um, shape D, that would be, I think it's UV, is also 16 meters. That could give us some marks there, okay? So again, there are some terms that come out with this similar size, shape, equivalent, perpendicular, right? So we can see that this forms a right angle in this corner, okay? So we should have a right angle in this corner, the same place, right? Here, this is not a right angle. This is not a right angle. We have no, a right angle would be in this corner here, and right angle would be in this corner here. Okay, can take this and pull it over, and they would fit exactly. So that's the first part. No, you stay here, and let's lock this in place so it won't move. All right, so that takes care of part A. Let's go to part B. It says, which pegs mark the boundary of Mr. Broomfield's parcel of land, and what is the shape? Okay, so let us remember that Mr. Broomfield bought one. He said Mr. Broomfield's parcel is one of the two congruent parcels of land. One of. So it's either going to be B or D. So let me see. If I chose B, then the boundary pegs are the little letters here that name, help us to identify, you know, the, the sides of the shape. Okay. All right. Boundary markers. All right. So, And this is important, for farmers. We don't want anybody stealing our land, or we are, stealing their land or encroaching on their land. So very important that we know our boundary markers. Same thing for housing schemes and so on. All right. So let's go. So if it is shape B, um, shape, let's get our pen. So for shape, shape B, um, boundary pegs would be, let's swap colors here, would be N S T U P, going all the way back to N. Some people include the N, some people don't, because it's already here. Okay, but it goes all the way down here. So let's go from let's see, from N to S to T to U to P, all the way back to N. Okay, it goes all the way back to N. Some people close the shape by putting the N there, but the N is already established, so we can see there. All right. Going back to N. Let me just put this here. So we go all the way around. All right. Now, if it was shape D, then the boundary pegs, let's put on the S there. Those would be, let's swap different color now. Those would be P. And it goes from P to U to, I think this one was V, to Q, all the way back to P. Right. Again, some people don't include this at all, but if we wanted to close the shape completely, then we would need to go from here, P to U to V to Q and back to P to close the shape. All right, that's why I'm including it. Some people don't. All right, so that takes care of that. Oh, no, we'll get half of the mark because we have given the pegs, because we are supposed to do two things. So one, let's go. One, we were to identify the boundary pegs, and then two, what is the name of the shape? So the name of the shape, so this shape is a trapezium. Okay, trapezium. And I think we'll get all our marks there. All right, to wrap this up quickly, we were supposed to find now the parcel by counting, and the area by counting. So we said the area of Mr. Broomfield's land, which is shape D, is, and we did some counting here. So we said 1, 2, 3, 4, and we use these two, right? These two half. So this would be 5, then 6, then 7, 8, 9, right? 9, 10, 11, 12, 13, 14, 15, 16, 16 and 2, 17, 18, 19, 20, 21, 22, 23, 24. So that's how we got 24 squares, and 24 squares times 4. Remember, we have to go back to our key, and this is one side, and we know to find the area, it would be side by side. So that's how they got the 4 there. Okay. So 24 times the 4. And so here we had 4 4s would give us 16. Right, 6 carry 1, 4 2s, 8 and 1, 9. That's how we got our 96 there. So the area is 96 meters, or 96 square meters. The last section here for this part of it, D, what is the perimeter? The perimeter of Mr. Broomfield's land, again, shape D is, and I'm going to look at the length of each side. So I have QV. Let's look for QV. that we had gotten at 11.32. So see our 11.32 meters there. And then UV, so this is UV or VU, that would have been 16. So we have our 16 there, have our two placeholders there. All right. Then UP, we could say, yes, UP, that's 8. Okay, remember we had 1, 2, 3, 4, but the length is 2, so 4 twos would give us 8. And then the final part now from P to Q to close the shape, from P to Q to close the shape would be 1, 2, 3, 4, 4 twos again, 8. So when we add all of that up, then we should get the total distance around the shape. Let's go. So we said here 2, and we have 2 by itself because 2 and nothing else, 3 and nothing else, decimal point under decimal point. 8 and 8 would give you 16, 16 and 6, 22, 22 and 1, 23. Write 3 and carry the 2, 2 and 1, 3, 3 and 1 would give you 4. So the perimeter of Mr. Broomfield's land here should be, and let's put this in blue, should be 43.32 meters.